Hello and welcome to Postgres FM episode 65. I'm Michael, this is Nikolay. Hey Nikolay, what are we talking about today?
Hi Michael, let's discuss backups finally.
Yeah, this has been on our list for a while, and I feel like this is a small win for me because finally you picked the most boring topic that we've ever had on the list. So yeah, I'm happy.
Boring and also one of the most important ones because if you ask some people why they migrate, for example, for RDS from self-managed Postgres, a very popular answer is I'm afraid I don't want to be responsible for backups anymore.
Yes.
Obvious reason, right? So
And not just backups, right? Like just the whole
of
process
course,
around it. Yeah.
but backups is on the first place of the list. Of course, the list can be long.
Yeah.
So, but backups is we are afraid to lose data. Of course, some projects are not afraid. Like some projects are not afraid to lose data, and they value availability more than data loss risks. So, like it's sometimes one is more important, sometimes the other, sometimes both. Actually, in most cases, both characteristics are important to be 100% available, or like 5 nines, 4 nines, 3 nines available, and also don't tolerate any data loss. But I see there is a tendency to say, okay, we can be down for some time, but we cannot lose any data at all.
Yeah, let's come back to that. I think that that is definitely a really interesting discussion. I think we should quickly talk about why do we even need what are the basics here first. I think that's a good trade-off discussion. But what are the basics? Why are backups something we need to care so much about? What are the main things we're protecting ourselves from or against?
Right. So database system should not lose data. If we inserted something, it should be present there. And the main internal mechanism not to lose data is write-ahead lock, first of all. So if we perform some write, it can be insert, update, delete. It first goes to this special system wall, write-ahead lock, and it's written there first. And not only written in memory, it's also written to disk. And if you have normal settings, if you committed your transaction, it means that the data is already on disk in wall. As for the normal data files, tables, indexes, not necessarily they received this change on disk. They received it in memory, but not synchronized to disk yet. This synchronization happens during checkpoints. But wall, it's definitely there. But unfortunately, sometimes we have, so if we have a failure, database system knows Postgres knows how to reach the old point of consistency, just replaying proper wall records since the latest checkpoint. And the bigger distance between checkpoints, the longer it takes to replay these changes, to redo these changes. But so it means that if a crash happens, we are good, database can recover itself. But unfortunately, sometimes we lose the whole server.
So, yeah, that's one reason, right? Yeah.
Right. Or we can, or something is broken disk with disk, for example, and we cannot achieve consistency at all, and we cannot start or something.
So I think you're on. I think you're listing the most the thing people think about first, but there tends to not be the time I see backups actually used most often. It tends to be protecting people from themselves or customers doing things that they shouldn't have done or didn't mean to do.
That's a great point, and this explains why replicas cannot serve for backup for disaster recovery purposes. There is such term, DR, disaster recovery. It's like a set of measures we take to avoid data loss and so on. So right, so I explained only problems from hardware. you're explaining problems from humans, and they're also quite common. For example, I deleted something and want to restore, but if you rely only on replicas, this change is already propagated on all those replicas, and it's hard to restore from there, right?
Well, I only mentioned humans that were doing things accidentally, and then we've also got to worry about people doing things maliciously, like taking data by like ransom attacks, that kind of thing. There can be other reasons why backing up your data can be really important, and having a copy of it somewhere.
Right, and in this case, it's not only you need to back up your data, you also need to store it in some secondary location, because there is special type of attack when if hacker steals access to whole cloud account, all backups in danger as well, not only Postgres servers themselves. And in this case, the risk to lose everything, including backups, is also not zero. And from this kind of problem, we can be only protected if we store data in some additional account, and only few people can access that account. This is hard to achieve, by the way, especially, for example, if you are an RDS user, you cannot store backups on, for example, Google Cloud or Azure, because RDS doesn't allow you to access those backups directly, right? You can store only dumps. Maybe it's time to discuss difference between dumps and backups.
Yeah.
So,
awesome.
Yeah.
Well, I was just going to say, I wanted to make sure we didn't move on without doing that. I think there is one more as well, actually, before we do move on, is that's like corruption. I think it gets mentioned a lot, but I tend to not see people. I don't tend to see it being the most used time for backups. So it's like people mention like your data could be corrupted, but people tend to like move forwards from that rather than go backwards, in my experience. At least sometimes, at least in the cases where the corruption is quite silent and hasn't been noticed for a while. For example, you don't know exactly when it.
There are mixed cases. For example, you cannot recover some table or part of some table, so you maybe fixed it somehow with resetting wall or something, which is quite risky. But if you have backups and you can perform point-in-time recovery, you can restore data that you lost, or you cannot read, and so on. Mm-hmm. So having backups is useful in this case as well. If you want additional reason why backups are useful, additional reason is you can provision new nodes. It can be replicas or it can be dependent clones. You can provision these nodes from backup system, from archives, not touching real live nodes, not making them busy with your cloning or provisioning activities. So this is also a popular reason to have backups as a source for node provisioning.
Yeah, good one. Right, so logical versus physical. And this is similar to previous discussions we've had in their definitions, right? So logical being
right.
Well, logical being taking it without bloat, maybe, is the simplest way of putting it. But like recreate the objects from scratch, insert the data from scratch, so recreating the entire database. Whereas physical would be at the file level, at the disk level, right?
At the block level, right. So, right, at file level, actually, also, right. So if you consider pgdump, pgrestore as a set of tools for backups, you're actually following official documentation, because it says pgdump is a backup tool. But a lot of database people, including myself, are against this phrase, because backups should have special characteristics, and one of them is very flexibility, right? So we can talk about RPO, RTO right here. RPO, RTO is two important characteristics for any backup system. RPO is recovery point objective, RTO is recovery time objective. It's maybe confusing, but one of them is about how much data you lose if you need to recover from zero, like from after some disaster. So for example, all nodes are lost, whole cluster, primary and all its replicas, all of them are lost. And RTO is how much time it's needed to recover. So one is measured, for example, in bytes, and other is measured, for example, in seconds. Good characteristics can be close to zero data loss, and roughly 1 hour for 1 terabyte to recover. Maybe it's too much. It depends, right? But
I think I was going to say, I think the genius of whoever came up with these is it forces the discussion of a trade-off here. I think if you ask business leaders what they want zero data loss and super fast recovery.
It depends. Well, yes, they want both, of course, right?
Yeah, they always want both, but this forces the discussion saying, well, which are you willing to let us have some leeway on here? Because zero data loss in 0 milliseconds is not possible, like generally. Like, you know what I mean? It forces that discussion, or is extremely expensive to achieve well.
Right. For example, you can have quite frequent cloud snapshots for your disk, and in this case, restoration, well, it still will be quite slow, a lot of minutes, not hours at least, right? Usually. But in this case, you lose some deltas between these points of snapshots. So if we go back to pgdump creates a set of SQL statements. This is what it creates. You can speed it up to go with multiple workers, and then you can speed up recovery as well. For example, if you do it during some maintenance window, or in case of disaster recovery, you can go with full speed, for example, taking number of CPUs, or knowing how your disk is, how disk capabilities look like, and saturating these capabilities, but not significantly, right? So in this case, we have both characteristics in very bad situation. First of all, pgdump, you cannot do it very often, especially if you have large database. Again, like roughly 1 terabyte per hour. Some people get more terabytes per hour, some people get less. It depends on your infrastructure. First of all, disk, then CPU, also network, important network. And second thing is, so you can do it only, for example, once per day, which is actually
means
quite often for dumping.
But means we might lose up to a full day of data if we're relying on that as our backup tool.
Exactly. And why you cannot do it often, also let's mention it right away. So if you do it often, you put a lot of stress. Each pgdump is a stress. We discussed it a few times. There is such setting, hot standby feedback. And in clusters where replicas are receiving read-only traffic, usually hot standby feedback is on, meaning that replicas report to the primary, I need this version of data, this snapshot, these tuples. So when you run pgdump, it runs transaction or multiple sessions in repeatable read isolation level. Right, it's higher than default. It's not serializable at least, but it's already higher than default read committed. And why it's needed? Why is it needed? Because we need to get consolidated snapshot of all tables, all data, and even if you do it in a single session, you still need it. If you do it in multiple sessions, behind the scene, it will tell all sessions to deal with the same snapshot, to get data in consolidated form, right? So in consistent data in terms of version of tuples, refreshing consistency, everything. So, and during this, you hold this snapshot, and this means that AutoVacuum cannot remove the tuples which became dead after you started. So you become a problem to AutoVacuum. And this means that even if we started on replica, since it reports to the primary, it's bad. So you can hold this snapshot for multiple hours, and during this we accumulate a lot of dead tuples, and later when we finished AutoVacuum will delete these tuples, converting them to bloat. This is how you can get a lot of bloat. Just perform frequent pgdump activities. That's it.
So we can't perform frequent pgdumps, so therefore we have bad RPO, but we also have bad RTO because...
Exactly, yeah. Because not only we need to load all the data to tables, we need also to rebuild everything. First of all, indexes.
Yeah.
And also verify constraints. Like we're starting from scratch. It's like we're not taking our database, we're taking fresh database with the same data. This is what the dump restore process does. It creates new cluster, completely new data, not cluster, database, but with the same data. It verifies constraints, and it rebuilds all indexes, and it's very CPU consuming operation. Of course, I/O also, but CPU as well. And if you have a lot of indexes, interesting thing that of course indexes are not dumped in terms of data. Each index, it's just one line like create index. Easy, right? But if tables are large, if you have a lot of indexes, it's a lot of work for when restoring. And it means that time to recover will be significant.
Yeah.
It can be
Great.
It can be even bigger in terms of time than data load itself if you have a lot of indexes. So building indexes can take longer time than loading data. And overall, it can exceed simple copy at file level. That's why base backup with wall replay might be faster.
So I think you've nailed I think you've nailed something, but I want to add something quickly, which is I don't agree that pgdump is not a backup tool. I think it is. I just don't think it's a good backup tool. And I think that would be like an interesting addition to the statement. I think everybody that says it's not a backup tool would be happy adding that word in, but other people can't disagree anymore. It's just not a good one. It's definitely not the best one available to us.
Well, yes, but like the third law of Newton, if you apply force, there is opposite force. So since documentation is quite strong force, this statement is so like bold and written very clearly, we need to somehow to mitigate this, right? So that's why we're trying to say, I agree with you, it's kind of backup tool, not ideal, yes. In some cases, it's fine for tiny databases, but if you have 1 terabyte already, it's definitely time to switch from dump. And I see so many projects, so many teams start with pgdump and then suffer quite long and then switch. I don't understand. But I think I blame documentation here, because they open documentation, see backup tool, and they have a false feeling they are fine until they are not. Like terabyte or like thousands of TPS and maybe even 100 gigabyte is already not good. So, and I see some platform builders also make this mistake.
Oh, really?
I'm not going to name.
Okay, good.
But yeah, it happens.
We should probably move on though to physical. Like, what should people be using instead?
Instead, we need to use physical backups. Unfortunately, if you are using managed Postgres, you just need to rely on they provide. And it's a pity that, it's not a pity, I think it's a huge mistake, and it's not fair that RDS and others don't provide access to backups. If those backups are regular Postgres backups, users should be able to reach them, to download them. But instead, RDS and CloudSQL and others they provide only access to at logical level. You cannot get your database. You can only get data from your database. I'm trying to continue my concept of like dump restore is like cloning your database. It's not taking your database. Taking database means taking data directory as it is, right? So if you're working with RDS, they do physical backups, but only behind the scene, right?
So yeah, this isn't something I realized actually. So you're saying there's a couple of tools for doing physical backups. For example, are PG Backrest or WallG. I can't use one of those to back up from RDS or the equivalents? Is that what you're saying?
You cannot, right. So the basic backup is just copying data directory with, for example, CP, SCP, rsync, doesn't matter. And of course, while you are copying the files, they are changing, right? And there is an internal mechanism to deal with this inconsistency. Basically, you can copy, but you will get inconsistent copy. And for example, you can perform cloud snapshot of your disk. Again, it will be inconsistent. I remember times when Google Cloud says they do consistent copy of disk. Then they remove these words from their documentation. So internal mechanism to deal with such inconsistency is two functions: pg start backup and pg stop backup. And you can do it on replicas as well. So you say pg start backup, you get a copy of your data directory anyhow, and then you say pg stop backup. In this case, this copy of data directory in pg wall subdirectory, there will be enough walls to reach consistency. So yes, data files are kind of from different points of time, right? But when Postgres will start, it will know that it was a backup. It was a copy which was created between pg start backup, stop backup functions. So there are walls, and we can replay them and reach consistency point. Great. Again, it's possible to do it on replicas as well. But of course, it's not super convenient. It's like low level. And I remember I like quite experienced DevOps guys had very big fears to do this approach. I told them, if we say pg start backup, oh, by the way, super important, this mistake is very frequent. If you say pg start backup, you need to maintain this connection. If you close
what happens if you don't?
You will lose proper files. And for example, if you do full backup using Volgy or other tools, same, you need to maintain the connection where you started this. So if you close this session, when you say pg stop backup, it will report that lost connection. So the like terabytes of data you just backed up cannot be used. So you need to be careful with this connection. And I remember how DevOps guys had fears to do this. Like, how come? Database is live, it's writing constantly. I cannot copy data directory. It's not possible. No, it's possible if you're between pg start backup, pg stop backup, you're fine. But it's of course it's low level. So to make it more convenient, there is a tool called pg base backup, which automates a lot of stuff. And I also remember some time ago, by default, it didn't copy WAL files. It was so many backups were created without WAL files. If you don't have WAL files to reach this consistency point, these terabytes are useless. You can move them to trash, to trash bin. So you need WALs to reach consistency point. But right now, by default, PG-based backup will take care of WALs as well. So you're protected right now. I also made this mistake, of course, not once. If you just follow, like in all documentation, you just follow steps, and like it's normal to forget about WALs, and then a few hours later you have a lot of terabytes backed up, but no WAL. So, but it's not enough. Why it's not enough? Because not only you need these WALs to reach consistency point, we also want to have almost like close to zero RPO. It means that we don't want to lose anything. And if our backup starts at midnight, but disaster happens at 11 p.m., we want all 11 hours of data, right? So we need to replay all changes. Perfect way to replay changes is WAL string, right? So we just need to have, okay, we perform full backups, for example, daily or weekly, but we also need to write all WALs. And for this, natural approach is to use archive command. Most backup tools use archive command. Only one tool I know which used different approach was Barman. It's still, I think it's already using both approaches. But originally Barman used different approach. It was like I'm a physical replica. I'm receiving changes on streaming
really?
replication. Yes, and I save this data. It's also interesting approach, but archive command is kind of more reliable and like it's standard de facto. So archive command just archives all walls. It's usually by default it's 16 megabyte files. On RDS I think it's 64 adjusted. You can also adjust it. So, but default is 16 megabytes, and each file is just compressed usually additionally. So there are two kinds of compression. I will describe if it's interesting. But in general, it's usually compressed to some smaller megabytes and archived. So if we have whole stream of walls without any holes and like overlapping or something, if it's consistent, right, we can replay until the latest available point, which means we can achieve near to zero RPO. But it will take time, increasing our RTO, which is interesting. Yeah. And replaying might be quite slow. Usually it's slow if your shared buffers is low. For example, sometimes we have additional replica with smaller number of gigabytes of memory, so we put we allocate fewer gigabytes to shared buffer and observe how replaying is significantly slower than original. So we have a lag accumulated. But without lag, very rough rule is like usually it doesn't take to replay, it doesn't take longer than originally it was, right? It should be much faster. So if we need to replay 11 hours of work, and of course we will be replaying less because some hours, it depends on the size of course, but some part of it will be replayed while we reach consistency point, right? Related to full backup. Yep. But then we need to replay more, and of course it should not take longer, usually at a few times faster, but still a lot. Maybe 10 times faster, depends on data nature, hardware, a lot of factors.
So what you meant? Yeah, what are our options then for reducing that RTO?
It's a great question. So some tools also offer delta backups instead of replaying changes as like replaying changes means like we are kind of becoming replica temporarily. It's same as having a physical replica based not on streaming but wall shipping. We just ship not from server, we ship from archives. Yeah. By the way, I forgot to mention, usually these days we keep backups on some object storage such as S3 or Google GCS or something like that. But so if you replay, it takes time. But there is an idea to have delta backups. Instead of performing full backup, we consider previous backup as the basis and just backup difference, delta. For example, we have every 24 hours we have full backup, and every 4 hours we have delta backups. Or every week we have full backup, and every day or every 6 hours we have delta backup. Why we still want to have full backup? Because maybe we don't trust fully to delta backups. They're quite fragile. But these days,
and you need a full one. You need a full one at some point,
to start,
right? Like
to start.
Yeah.
Right, and then you need to apply multiple deltas, and then I replay additional walls between deltas. We still have some distance in time, right? So it's like three-stage process: full backup, applying deltas, and then applying walls. Yeah. Right. So this can speed the process up, definitely, and also reduce space, because if you perform full backups every day, it will cost you in terms of object storage price. So.
Yeah. So what do you tend to use? I think you've said previously you tend to use WallG for like the management of these full backups.
Let me
Go on.
finish with. I just realized there is also obvious idea that, and I know platforms they use this approach themselves. Instead of restoring full backup, base backup from archive, which will take time, we can just restore a snapshot of disk and then apply walls, and this can be super fast. Minutes.
Interesting.
For many terabytes, it can take minutes. AWS, GCP, they all offer snapshots of disks. The restriction here is that you can restore only to new disk usually. You cannot restore, for example, two backups on one disk. You need to create a new disk and restore from this cloud snapshot. But it can be super fast. And unfortunately, for example, Volgy doesn't support, I cannot say, I have snapshots, let's consider them instead of full backups, let's consider snapshots and just perform all orchestration around it and just apply walls and so on. I'm not sure about pgBackRest. I also think it's so, yeah.
I think I read something in the docs that reminds me of this. They called it Delta Restore, I think. Actually, I'm not 100% sure, but I think they might support this.
Well, but Delta Restore is about Delta backups.
Well, they call those full differential and incremental backups.
If documentation talks about details for particular cloud platforms such as AWS, GCP, and so on, then probably it's supported. So
they do talk about S3 Azure and GCS compatible object store support.
Well, it's different. It's
True.
Location for full backups and walls. It's where we store our archive.
Yeah, good point.
But the idea is restoring full backup and deltas as well from zero, from scratch. It takes a lot of time increasing our RTO. And we need to move faster because if it's disaster, our service is down. In this case, cloud snapshots and restoration of disk, full disk from such snapshots, it's good. So, we can consider them instead of full backups and then just perform point-in-time recovery to the latest point using wall replay. Restore command is responsible for this. We just configure our new fresh Postgres to continue restoring, replaying changes from archive, and then we reach the latest point. In this case, you can achieve quite stable and kind of predictable RTO, which will be almost like dependency of this RTO on the database size will be minimal because, it will be, but it will not be such significant as for restoration in traditional way from full backup. So, you have 50 terabyte database. It takes 15-20 minutes to restore from cloud snapshot, and then you just need to replay. It depends on how active this database is during a day. If you need to replay up to 24 hours, in the worst case, for example, if we take snapshots only once per day. Actually, we should take snapshots more often. In this case, 24 hours is quite a lot, but maybe it will take a couple of hours if hardware is good. Right.
Yeah, interesting. It does, for smaller databases though, you said it's not that dependent on database size anymore. I would guess for smaller databases it would still be significantly faster.
It can take a few minutes. For example, if you have 1 terabyte, you can restore in a few minutes for example, 1 terabyte, every 4 hours we perform full snapshot, cloud snapshot. And we, for example, have, half a terabyte, no, that's too much, 100 gigabytes per day worth of wall data. It's good to know, by the way, the distance in terms of bytes between 2 points, how much during busy day, how much of data is written to wall. And you can expect backups in this case. And for example, Barman reported just number of gigabytes, it was good. Volgy doesn't report, but it reports LSN positions. If you take 2 LSN positions, you can just subtract one from another, and difference will be in bytes.
Yeah,
and then cool. And I do it all the time. So you know the difference. Okay, I generate 100 gigabytes per day. Replaying 100 gigabytes on quite good software, it will take dozens of minutes, maybe just minutes. In this case, our RTO will be, we can achieve RTO below 10 minutes in this situation, which is good. And almost zero RPO. I just explained the recipe for good characteristics of backup system.
Yeah, nice. I feel like there's one thing we haven't talked about yet that I feel super guilty not mentioning in an episode on backups, and that's testing your backups.
Right. So we need to remember two mantras about backups. PageDump is not a backup tool, and you didn't convince me.
Not a good backup tool. Not a good backup tool.
Okay, not a good backup tool. Okay, good. And second mantra is not tested backup, is a Schrödinger backup. It means it's not backup as well. So we don't know. The state of this backup is unknown. Even if the tool which performs full backup exited with code 0, meaning no errors, who knows, is it restorable?
Well, and this isn't just a philosophical question, right? Like, there are real things that could have gone wrong, right?
Yes. So my personal story is I was reading Hacker News in 2017 in February or March, in March maybe, I don't remember exactly, I think in March. And I was reading about GitLab case, of course. They lost a lot of data, and they had many backup methods applied, but poor testing of backups, and they lost data. So there is a good, not super accurate, but entertaining YouTube video about that situation in 2017, which explains it like in very entertaining form what happened. But again, like, kudos to GitLab team. Many years they share everything with community, with wider community, not only those who work with Git or Ruby, but also Postgres. And I remember I was super curious to know about details and to learn from mistakes, of course. And then this is actually how we started to work with them. And backup system remains to be super important focus, not to allow any issues anymore. So testing is super essential. And ideally you need to test every full backup, and not only every full backup, but also whole wall stream. So you need to verify that you can restore from backup. The Postgres starts. This is like minimal verification. Postgres starts and can receive connection. Ideally, you should check data which is there, right? Reading some data. Some people tend to dump to DevNow to verify that the all table data can be read. PGDump to DevNow. It does mean index data can be read, for example. Indexes can be corrupted. And some people tend to use AMCheck, and we discussed how to deal with corruption risks. So AMCheck is a good tool. PGAMCheck with -J, as many vCPUs you have, because this machine probably is temporary. Also to check that index data can be read. But it takes time as well, so it's expensive to perform such operations. Maybe not every time you want to do it. But also you need to verify all walls, and ideally you restore from one backup and replay all walls until the point next backup. Right. This is whole verification.
That's I think it's worth saying that you're testing for the reasons it could have not worked, right? Like you're checking that it's not empty, or that it's not. You might want to check
it's
for
restorable.
Recent data. So you check that it's restorable because it hasn't failed. The restore hasn't failed. So that's a great starting point. You're checking it's not empty. That's a potential failure. Maybe you're backing up the wrong database within your. Maybe you're backing up one of you know what I mean. There's so many things that could have gone wrong. Checking it's not empty. I like the idea of checking for recent data. Making sure it's not an old backup by mistake. Yeah, exactly. So there's a few kind of smoke tests you can do. I think I've seen some people doing counts of tables, but I don't think you need to do anything you can do as much as you want. Obviously, maybe the more the better, but there's a limit to how much we want to do, I guess.
Right, so we can talk about two classes of verification here. First is infrastructural class. So restorable and wall stream is fine. We can replay until next backup. And actually, you can skip the second part here if you have a replica which you monitor well and it's based on wall shipping. If that replica is fine, it's constantly replaying from backups, it means walls are fine. But if you don't have such replica, you need to do it during your backup verification. It will take time again to replay all walls. But you will know your RTO better from such logs, right? And second layer is logical. This is what you described. Timestamps, counts, we can read data and so on. So uncheck, corruption at logical level.
Last question. I'm conscious of time, but you mentioned it's difficult to get physical replicas from clouds. How do you tend to do it? It's
impossible, not difficult, it's impossible. They don't provide access to PG data, they don't provide access to backups, and they don't provide physical replication connection. Some of them do. Crunchy Bridge, they provide access to physical backups. This is a great example. So, when we say, this is your data, you can take it, well, yes, but not only I want my data, I want my database. If I pay for it, I pay bigger cost than to EC2. Of course, I pay for backups to work, for HA, everything. I want my database. If it's Postgres, give me this Postgres. I want data directory and I want backups.
Last thing, I was wondering if doing logical replication to maybe a self-managed instance and then backing that up with the fit. I'm wondering about having a secondary one offsite. Maybe that it's not perfect because you've got the logical replication lag, but it's better than not having one, maybe.
Well, again, we discussed there are two types of problems. Again, physical and logical. Physical, for example, something happens with hardware. Logical, human mistake or intentional attack and deleted data. If it's logical replica without lag, and the change is propagated there as well, and so you cannot recover from replica in this case. Some people tend to have delayed replicas.
I'm talking about having a logical replica and backing up, doing a physical setup, physical backup from that, having PG backrest running off your logical replica.
Well, yes, it's possible, but again, it's same data but different database. I mean, you will not get your bloat. And sometimes we want to get our bloat because, for example, for some kind of research, if some incident happens on production, we want carefully research what happened, perform root cause analysis. In this case, we want exact copy of our data, exact clone, including all the bloat, how data is distributed in tables and indexes. And logical replica has different distribution of data.
Yeah, all I was thinking was maybe you might be able to achieve lower RTO, RPO on a cloud system, even in the event of a major outage on that cloud, for example.
Well, ideally, you should use what cloud provider of managed service provides you. For example, RDS, they have good reliable backups. I don't see details about testing of those backups. I cannot test them myself except restoring to some kind of explicit restoration and running some tests. But we kind of trust them because if these backups were not reliable, we would see a lot of blog posts, tweets, LinkedIn messages about it, right? We don't, so they are reliable. They have large scale, right? But I don't like it's not open source. It's kind of, they say it's Postgres, but I don't have access to database. I have access only to data. As I say, heavy clouds are gathering upon open source, you know.
Is the cloud pun intentional?
Right.
Yeah. All right. Should we call it there?
Quick mentioning, some people who control their databases, not only data, they also consider using delayed replica because physical replication allows you to having replica which is 8 hours behind, for example. And this is exactly for the reasons of faster recovery of some something was deleted, let's replay only a few number of minutes or hours quickly. If we do it quickly, because if we already passed, like something happened, but we learned about it already 10 hours later, but our delayed replica is 9 hours behind. It's already too late.
Yeah.
And of course,
You're on a
having
stop-
such replica is...
Or even if you find out about it like 7 hours later, you're on like a stopwatch for you've got an hour to fix this problem.
Right. But you can quickly pause it.
Oh, true. Yeah.
Yeah.
Good point.
Stopping replay. And then you can know when exactly the problem happened and replay exactly like 1 second before it, for example, and extract data manually. It happens. Sometimes it's a good idea to have such tool. But for example, database lab users, they have even better. They can provision clone, and there is a recipe to replay walls. If a database lab engine is working based on physical replication, walls from archive, for example, you can create a snapshot which corresponds to time before the point of incident. Then you can replay again from point in time recovery. There is a recipe. It's not fully automated, but it's definitely possible. And then you can achieve very, very good RTO in this case. This is for partial deletion when manually we deleted something. Yeah.
Cool.
Good. I think we
we should call it
covered all main principles of backups. It's not super deep material, but at least it's something. Maybe one day we will discuss more deeper things,
Or specific tools, maybe. Awesome. Well, thanks so much, Nikolay. Thank you, everybody, for listening, and catch you next week.
Good. See you later. Bye.